back, everybody. Today's video is talking about integration. So we've done derivatives, so let's go backwards. Now, the very first aspect of going backwards is the antiderivative. What's nice about this is you just take a look at your derivative, find a function such that when you take the derivative of that new function, it comes out to what you originally had. So that's pretty straightforward. So if you have the function of f of x equals 5x to the fourth, well, knowing your basic power rules, you should be able to find an antiderivative of x to the fifth. But you also have x to the fifth plus 7 would be an antiderivative. The only difference between these is a constant, which that will always be the case for your antiderivatives. Whatever you have, change it by a certain amount, and it'll still be an antiderivative, but it won't be the same function. So what we do to take care of this issue is deal with the indefinite integral. Now, what is the indefinite integral? It's the function which is all your antiderivatives together. Well, that seems like it'd be a bit difficult to do, but it's not too bad. So first thing, when I'm asking you for the indefinite integral, I'll ask it in this type of form where I want the integral, that is what this line means, of the function f of x with respect to dx. All right, not too bad. Now, to write the indefinite integral solution, you just take the most basic antiderivative you have and then add c to it. So if you have the function 5x to the fourth, well, the basic antiderivative would be x to the fifth. So that means the indefinite integral would be x to the fifth plus c. So c is some constant. So you put any constant you want in for c, and that's still an antiderivative. All right, now, some of them will be based on certain situations you will know, in which case you have to find out what c should be. Now here's some basic indefinite integral rules. So if you know your basic power rule, well, you can work backwards. So you add 1 to your exponent first, and then divide by your exponent. So you do the opposite way you did before, and then of course add c. This does not work though when n equals -1. In this situation, you need to remember your natural log derivative is 1 over x, which is the same thing as x to the -1. Which here means your antiderivative would be the natural log of the absolute value of x plus a constant. Now, why do we have the absolute value? Because if you have 1 over x, well, you can put anything but 0 in there, including negatives. But you cannot take the natural log of a negative. Therefore, we need the absolute values. When we were doing it the original first way, well, you can't put negatives in the natural log, so they weren't even in the domain, so it didn't matter. But when you're doing the other direction, it does matter. So do not forget the absolute values inside your logs when you're doing indefinite integrals. And then there's the basic exponential, which you can see the exponential doesn't change, but you multiply by the natural log of your base. Well, for the indefinite integral, you divide by the natural log of your base, and then add a constant. All right? Now, let's take a look at an exercise. YouTube started around mid-2005. But we can find a formula which tells us the hours of video uploaded per year. All right, so we know it's a rate already. So that means we can go backwards to find just the hours of video at any given time. All right, so t goes from 2005 to 2016, and 0.5 would be the beginning of 2005, which we're assuming there's not going to be any videos on YouTube when it first starts. All right. So I want you to find the antiderivative of each part and figure out from there. So go ahead and try it out. All right, hopefully you've gotten these for antiderivatives. We're not too worried about the constant in the front. It's not going to change much. All right, so go ahead and try and figure out the next step. If you haven't been able to do it, you just need to put them together back in the proper order. All right, so go ahead and try that. All right, if you're still having issues with that, you should get something along this line. Now, we know an initial condition. Therefore, we can find what c is. So go ahead and plug those values in and see what you get. Should have this. So putting 0.5 in for t and putting the entire thing equal to 0. So go ahead and solve for C. All right, hopefully with your solving, you get that C is 76,125. Okay, so your final equation should be this here. All right, hopefully you learned something, and I'll see you in class.